Creating orthotics using digital technologies like 3D scanning, 3D modeling, and 3D printing has been a very long and complex process with a fragmented workflow. If at any time you have reviewed 3D printing over the last decade or so, you may have decided that it wasn't best for you because it was a very time-consuming process. Well, follow along with me now as I model a hand orthosis using the Spinties application for iPad and see just how far 3D technology has come. Here in the app, you could see that I've already taken the 3D scan, I've modified it, and the last few seconds of this video, I have started drawing my trim lines, being mindful of the bony prominent areas, and I kind of contradict myself there as I draw right over that, but in a few seconds you'll see how I correct that. But using my finger and touching the 3D scan, I'm able to draw the trim lines almost like I am sculpting on the orthosis to the 3D scan. At this part of the workflow, I am cleaning up any of the rough surfaces. You don't have to be super mindful of the rough surfaces, you'll see in just a second, but it's good to always go around and double check your work just in case there's any material on any bony prominent area. And in fact, you'll see in just a second. Now, when I press next step, those edges get really smoothed. So you don't have to spend so much time fine-tuning every single edge because it does it for you. Now, here you have the ability to vary the thickness in certain regions, but before I did that, I realized that's a little bit too close to that second digit's knuckle. So I'm gonna take off this closing side here and redraw it. For some reason, I'm just not liking the thickness of that trim line. So I'm gonna adjust the brush size to the lowest that it'll go, so I have more freedom and control of the design tool. When I go down to the 13mm brush size, I'm able to really fine tune where I want the material to be. And I'm just really touching up the orthosis now. Press next step. You see that the edges are automatically smoothed. Here again is where I could be able to vary the thickness if I wanted to, but I'm gonna go for a global thickness. I get a nice preview of the STL file on the modified scan and can adjust the actual offset of the device there, but I didn't need that, so I'm gonna move forward to actually placing my belt loops. Touching the 3D model with the node, I'm able to understand if I'm too close to the edges, and if I am, it won't let me place it, but if I'm not and I like the position, I can press next and then the belt loop will be placed. I'll have the option to, and had the option to adjust the clearance, and that's important so that you could be able to have your Velcro strap actually going through that belt loop so that donning and doffing is easy. I made it a little bit more thin, low profile. I'm gonna add a rivet hole to the opposite side so that you don't have to worry about taking the device really to the back of house. You can literally just add your snap rivet or whichever rivets that you have and move quickly to fitting the patient. One of the last final steps is adding my serial number, which is really cool because if this device ever came back to you and you needed to investigate certain things about that device, you could be able to track it back down to the very time it was printed, who printed it, who loaded the material. It's a very nice process for traceability. One of the last things here, just filtering through the appearances of the 3D scan, double checking, making sure that the orthosis is how I'd like it, and I export my file. That's it. That's the Spinties workflow.